Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will see how to create ADVS dataset for a parallel arm study. So which is ADVS stands for Vital Signs Analysis Dataset. So let us take a quick look at the lesson description to see what we will cover in this video. So we will see complete program for ADVS of a parallel arm study. It includes derivation of param CD, param N, param, parcat1 and parcat1n variables derivation. It also includes baseline flagging and dependent variables creation, which includes creation of ABLFL, base variable, change variable, and percentage change variable. It also includes creation of an analysis flag, which is ANL01FL. So this flag is used to identify or select one record per subject per analysis visit per parameter. And we also create a flag called ANL02FL. So this flag is used to identify the post baseline records. So let us now move to the specification for this lesson. So we have the specification given here. We have the variable name, variable label, and the derivation logic that has to be used is given here. So the main dataset that will be used as input for vital signs analysis dataset is our SDTM vital signs dataset. And we also fetch some variables from the ADSL dataset, which is already programmed. So here, similar to the previous videos, the convention is when the variable is a copy variable, the domain name, which is vital signs, and the variable name is listed here. So study ID is a copy of study ID from vital signs. Similarly, the subj ID is a copy from vital signs raw dataset or the SDTM dataset. So and we have few variables that are to be fetched from ADSL dataset, which is subj ID, site ID, age unit, sex, race, from ADSL dataset. And then we have VSSeq, which has to be fetched as a copy from the SDTM VS dataset. And then we have our first derived variable, which is ADT, so which is analysis date. So we are being asked to populate it using VSDTC. So VSDTC is a datetime variable in character format. Analysis date is a numeric variant of it. If we have date and time components, ADT will be used only to capture the date component of it. So here in this case, so we only have the date collected in vital signs, so we only have ADT and we do not have the associated time variables. So if we have time also collected, we will be making use of the same variable, but the time component will be used to populate the ATM and ADTM will be used to populate the date and time values. So, and then we have the derivation for ADY, which is analysis relative day. So here it says populate using ADSL.TRT-STT and ADVS.ADT. So if ADT is on or after treatment start date, then populate as a difference between ADT and TRT-STT and add 1 to the difference. So which is ADT minus TRT-STT plus 1. So if the ADT is on or after treatment start date. Otherwise, if ADT is before TRT-STT, then populate as the difference between ADT and TRT-STT. So which means ADT minus TRT-STT. And then we have epoch variable, visit num variable, and visit variable. So these are copies from the SDTM VS domain in ADVS dataset. And then we have our analysis visit variable. So it says populate with vs.visit for scheduled visits and leave null for unscheduled visits. So for a record, there could be values of corresponding to a scheduled visit or unscheduled visit. So we are being asked to use the value from vs.visit for a visit when it is a scheduled visit. And for unscheduled visits, we are being asked to leave it to null. And there is a second component involved in a visit derivation. It says populate as baseline on baseline records. So which could be identified using advs.ablfl is equal to y. So if we see here, so a visit can be partially assigned for the records which are by using visit variable from VS, but it also is dependent on a second set of condition, which is ADVS ABLFL is equal to y. So which means in order to complete the derivation of a visit, we also need to have ABLFL created first. So let us now move on to the next specification, which is for a visit n. So it says populate with vs.visitNum for scheduled visits and then leave null for unscheduled visits. populate as 0 on baseline records, which is advs.ablfl is equal to y. The records with advs.ablfl is equal to y. So here the definition for a visit and a visit n is in parallel. So for a visit we are using visit values and visit num values. So for a visit of baseline record we are populating it as baseline, and for a visit n we are populating it as 0. And then we have vs pos. So for position variable we are uh, being asked to populate it as a copy of the HDTM vs variable. And then comes our parameter variable. So we are being given the full param values that have to be used for each of the param CD values, which means that we'll have to check for the derivation of param CD first. So param CD says, so populate with the values from VS test CD. So this is a very simple vital signs domain. There are no additional parameters are being created. All the parameters are actually copies from vital signs uh, SDTM VS. So we are directly asked to use the values from VS test CD variable for param CD. So you, after this param CD value is created, we will be able to create param value by checking the values in param CD variable. So we are being asked to populate it as systolic blood pressure in mmHg. So when the param CD value is sys-BP, and for dia-BP, so we are being asked to populate it as diastolic blood pressure in mmHg, and similarly the specification is given for all the other parameters. And then we have paramen. So similar to param variable, so we are being asked to create paramen value using the values present in param CD. So here we are being asked to use a value of 1 in paramen for sys-BP and 2 for dia-BP and so on till 7 for weight parameter. And then we have parcat1. So this is again coming as a copy from vscat, but getting assigned to a new variable called parcat1. And then we have parcat1n, which is numeric variant of our parameter category 1. So populate using vscat. So it says populate as 1 when vscat is equal to vital signs, and populate as 2 when vscat is equal to physical measurements. And then we have VSORRES and VSORRESU, which are copies from SDTM VS domain. And then we have eval variable, which is populate using VSSTRESN. So we are being just asked to assign the value from VSSTRESN to a variable called eval. And then we have our base variable. So it says populate using ADVS.eval on the record where ADVS.ablfl is equal to y of each parameter and subject on all records of that subject and parameter. So we'll have to identify the record which will have that ADVS ABLFL is equal to y for each parameter and subject, and use that value and populate it across all records of that subject and parameter in a variable called base. And then we have our change variable. So it says populate as the difference between advs.eval and advs.base. So which is advs eval minus base. But we are being asked to populate change variable only on the post baseline records. And we are also given the condition that can be used to identify the post baseline records. It says ANL02FL is equal to y. So which means before we create change variable, we need to have our ANL02FL in place, or we need to have that derivation ready or available for us in the programming. So similarly for base also, if we see here, so we need to have our baseline records identified with ABLFL is equal to y to create base here. So these are the dependencies on other variables. So we'll have to handle or create the program to create these preceding components first, so that we can derive the subsequent or the specific variables where we have dependencies. And then we have percentage change. So here it says populate using change and base. So as change divided by base multiplied by 100, so to convert it into percentage. And then when base is not null and it is not 0. So because base is becoming a denominator here, we cannot populate percentage change when the denominator is 0. So that's why we'll be only able to calculate percentage change when the base value is not missing and not 0, because we cannot divide a number with 0. And then we have our ABLFL, which is the baseline record flag. It says populate as Y on the latest record with non-missing result on or prior to treatment start date. The treatment start date can be fetched from ADSL from the variable TRT SDT for each subject and parameter. Just populate as Y on the latest record with non-missing result on or prior to the treatment start date for each subject and parameter. So there can be one or more records prior to the treatment start date, on or prior to the treatment start date. So if there exist multiple records, so we are being asked to use the latest record and flag that record as baseline record. So which could be which is our ABLFL. So ABLFL will have a value of Y for each subject and parameter, which will be considered as the baseline record. And then we have our ANL01FL. So the variable label for it is analysis flag 01. It says populate as Y on the latest record within each analysis visit per subject and parameter. So if there can be cases wherein there exists more than one record within a visit for each subject and parameter. In that case, so when we are creating the tables, so we will have to count a subject only once at each visit. So for that purpose, we need a flag to identify the record that have to be used in the table. So we are creating this variable to identify such records and select the record which has to be used in the table level. So we will have it populated on the latest record when there exists more than one record within a visit per subject and parameter. So all of these individual concepts are explained in detail using data scenarios and manually identifying the cases, and those videos can be found in the ADaM playlist. So ANL02FL is there, and then it says populate as Y on the post baseline records. We are being given the condition which says ADVS.ADT greater than ADSL.TRT-SDT. So these are the records. This is the condition that can be used to identify the post baseline records. On all the records which meet this filter condition, we'll have to populate Y in ANL02FL. And then we have safety flag, randomization flag, and enrollment flag being pulled from ADSL dataset. So this is the specification for our vital signs analysis dataset. So we will now move on to the programming. So here on the left hand side I have my program, and on the right hand side I have my input dataset and also all the intermediate datasets that are getting created from this code. So similar to the previous lesson, so I have the code that creates the input datasets for this lesson in a program, and I am including that program in this using the %include statement. So when this line of code is executed, all the code present in that second SAS program gets executed, and all the datasets are available for me in the work library for me to program this task. So now move on to the core programming. So it says get treatment start date into vital signs. So we have our input for ADVS as discussed earlier. SDTM vital signs dataset will become the base dataset, and as we need some information from ADSL will also become an input dataset for this. So here as the first step, what I'm doing here is sorting vital signs dataset based on the values present in study ID and USUBJD variables using proc sort. Similarly, the ADSL dataset is also sorted. And then I am merging ADSL to my vital signs dataset at subject ID and study ID level and creating a new dataset called VS01. So here in this initial merge, I am only fetching the treatment start date from ADSL into my vital signs dataset. And if we take a note here, we are keeping all the records which are coming from vital signs dataset. So there can be cases wherein there are a few subjects in ADSL dataset, but there is no record in vital signs for dataset for that subject. So we do not need a record for such subjects in ADVS. So we will have to keep only the records for the which are coming from vital signs. So we are making use of that filter condition using if A. So we are identifying all the records which are coming from vital signs and then keeping only those records. And then here we are removing the records where VSStat is equal to not done. For analysis purposes, we generally do not use the records where the VSStat is not done. So I am removing those records here. So my base dataset here has become VS01. So we'll be using VS01 to create additional variables. So it says then the next step what we are doing here is create variables which are directly based on input variables. Similar to the previous dataset where we have seen there will be some variables which are direct copies of the SDTM variables, and there can be some variables which need some minor manipulations. So we can create all those variables in this step as the starting point. So here we are creating parameter related variables. So here if we see, as mentioned in the specification, param cd is equivalent to vs test cd. So I am assigning vs test cd values to the variable param cd. So and then in the next step what I'm doing here is, so we have been given the values for param and param n based on the values present in param cd. So I'm assigning param and param n for each of the param cd values. So within using do group processing. So I'm checking for the condition once and executing two statements here. So I have done this processing for all the variables, all the test CDs or the param CDs. Says BP, BP, heart rate, respiratory rate, and temperature, height, and weight. So I am assigning param and paramen for all 7 parameters. And then for parcat1, we were asked to populate it directly based on VSCat. So I am directly assigning that value to parcat1, VSCat to parcat1. And for parcat1n, we were asked to populate with the value of 1 when VSCat is equal to vital sign. So I am assigning that using a if then else statement. And then for parcat, VSCat is equal to physical measurement. So we were supposed to assign value 2 to it. So I'm doing that here. And then we are creating some timing variables. So we were asked to populate ADT using VSDTC. So ADT is a numeric version of VSDTC. So we can only create numeric date versions when the date is full. So when the full date is present, the length of VSDTC has to be at least 10. So I am checking that for that condition whether the full date is present or not with this condition. So why will this become 10? So because we know that in SDTM ISO 8 in SDTM date variables are present in ISO 8601 notation. As for that value, so we will have the first 10 characters populated using date value. So which is 4 character year followed by hyphen followed by 2 character month followed by hyphen followed by 2 character day. So if we have full date, the length will be at least 10. And if we have time also, then we'll have the letter T and then we'll have the time after that. So I'm ensuring that the full date is present. And in that case, I'm creating ADT by using VSDTC and converting it into numeric format using YYMMDD10.in format. And then after that, we are creating our ADY variable. So we will be able to create ADY only when both the components, input component, which is ADT and TRT SDT are present. So I am checking if both of them have a non-missing value using nmiss function. So nmiss function actually returns the number of variables that are passed as arguments with a missing value. So when both have to be present, we are expecting the value to be returned by the nmiss is equal to 0. So we are checking for the presence of both the variables. So we could alternately write it this way. So if the ADT is not is equal to missing and TRT SDT not is equal to missing, then do. So and then so we were asked to populate ADY as ADT minus TRT SDT if ADT is less than TRT SDT. Otherwise, if ADT is greater than or is equal to TRT SDT, so we were asked to populate it with the value of the difference between ADT and TRT SDT and add 1 to the difference of it. So we are doing that here. So now ADT is done, ADY is also done. And so we had two components in AVisit derivation, for AVisit and derivations. So the first one was to populate AVisit n with the values from visit number, and the second component was to populate it as 0 for baseline records, and for a visit we were asked to use the value of baseline for the records with ABLFL is equal to I. For other records we were asked to use the value of visit variable for creating a visit on the scheduled visit records. So what we are doing here is we are checking for the presence of the text unscheduled in the visit variable, and if it is 0, which means for all the other scheduled visits, the text unscheduled will not be present in that. So when it is 0, which means those will be the scheduled visit records. For those records, we are assigning visit num to a visit n and then visit to a visit variable here. So we are also making use of this third argument in the find function, which is the letter I, which says ignore case. So which means it ignores the case when comparing the text unscheduled values when in the visit variable. So the unscheduled could be present in uppercase, proper case, or lowercase. So when we use this letter I, so which means that the third argument of the modifier, so it says that ignore the case when comparing the value of unscheduled in the visit variable. So if we are using index function, what we need to do is we need to write lowercase of visit and then put the unscheduled here in uh, lowercase, or otherwise we will have to convert the values in visit value to uppercase and then put the unscheduled here in all capital letters. So because we do not have the third argument or the modifier in index function, so find function we will be able to easily make use of the third argument of ignore case. That's why I am using find function here. So, and then we will move on to the next variable. So for eval, we were asked to directly use the values from vsstresn. So I'm just assigning the values from vsstresn to eval variable. So we have now completed the derivation of some of the variables which are either direct copies from SDTM or which need some minor modification based on the variables present in vital signs domain. So if we take a quick look at our ADVS 01 dataset, so let's scroll towards the right, we'll have all the variables which are newly added. So we have created param cd, param, paramen, parcat1, parcat1n, adt, ady, avisit n, avisit, eval. So one thing to note here is that we have not completed the full derivation for avisit n and avisit. So we have only handled the first portion of it. So we'll be completing the derivation of these two variables in the subsequent step after deriving ABLFL. Now move on to the next step. So we are now creating baseline flag and dependent variables in the next section. So now the first step is to identify the baseline record and then populate base and then create our change from baseline and percentage change from baseline. So for baseline flag, we were asked to populate it on the latest record with non-missing result on or before treatment start date. So we will be able to identify the records which are on or before treatment start date with this condition: ADT less than or is equal to TRT-SDT. So if you are being asked to check only the records which are prior to treatment start date, all we need to do is change this less than or is equal to less than, and then we are checking for the presence of a result, so which could be checked for, and eval not is equal to missing. So one thing to note here is that as all the parameters in this vital signs dataset are numeric, we are directly checking for eval not is equal to missing. There can be cases wherein there could be some results which could take only character values. So in that case, we will have to check for eval C as well, the analysis result or the standard result character from the corresponding SDTM dataset. So here ADT less than or is equal to TRT SDT and eval not is equal to missing. So here in this base 01 dataset, we will have one or more record per subject per parameter which are actually on or before treatment start date. If there exists more than one record, so we were asked to use the latest record. So for that, what we are doing here is use subject ID. We are sorting the records based on use subject ID, param cd, ADT, visit num, and vsseek. So if there exists more than one record within a subject and parameter, when we sorted by ascending date, the latest record would be at the end. So we will be subsetting for that last record within each subject and parameter in the next step. So if we see here, we are creating base 01 using base 02 using base 01. So and we are indicating to the data step that my data is sorted based on subject ID, param cd, ADT, visit num, and vsseek. So as when there exists more than one record within a param CD, we know that the latest date value would be sorted at the last. So we are using if last.param CD. So to select the latest record, and then we are assigning the value of y to ABLFL variable, and we are creating a variable called base by using the value from eval variable in this record. So in this base 02 dataset, what we will have is we will have one record per subject per parameter, and that record is actually our baseline record. So, and in this dataset we are keeping only the required variables: u sub jd, param cd, adt, visit num, ABLFL, VSSeek, and base. So we will be using this dataset to populate two things. One is our ABLFL and the second one is our base variable. So let us take a quick look at base 01 and then base 02 datasets. So here, if we take a look at our ADVS 01 dataset, so how many records we had? We had 52 records here in this dataset. And if we take a look at base 01, so all these records correspond to the records which are on or prior to the treatment start date. So we only have 28 records. So out of all uh, 52 records, so we have 28 records which are eligible for getting classified as baseline. So in the next step, what we have done is we have selected one record per subject and parameter. So we have all 28, which means there were no subject and param CD which had more than one record during the screening period or the baseline period. So if we had more than one record, the number of records could have been more here, and then the records would have been reduced by some number, because all the previous instances, which is not the latest, those records would have been deleted in this step. So in this data which we are seeing here, so we have only one record per each subject which is on or prior to the treatment start date. So we have now created selected the latest record, and then created our ABLFL record and base record. So we know that, say for example, for subject 1004, for param is equal to 1. So the ADT is 2nd Jan 2010, and that record is becoming baseline for this subject. I think this data is not loaded in the latest format. I'll pause the video and then try to get the latest data loaded. So what I have done here is that earlier we had param n variable here, but I was keeping param cd variable here. So I made that change, but the data here on the right hand side was not loaded properly. So I pulled the latest data, which is now reflecting with the latest code available here. So for each param cd, so we now have the date and the corresponding VSSeek, which is actually our baseline record. So now we will be able to use the subject ID variable, param cd, visit number, ADT, and VSSeek from this dataset to populate our ABLFL value on a particular subject and param cd. So in the next step, what we are doing here is we are using our base dataset, which is ADVS 01, and then merging our base 02 dataset to it. So at the time of merge, so what we are doing here is, so we are keeping u sub jd, param cd, ADT, visit num, VSSeek, and ABLFL. So the variable that we have not kept is base. So why this is not kept is because ABLFL is a particular time point record. So here for subject 1004 for dia-BP, so the record with VSSeek 1, which is having a visit number of 1 and ADT of 2nd Jan 2010, is our baseline record. But for base, so we were asked to populate it across all records of that subject and parameter. If we had kept base variable here, it would be populated only on the record where the sequence is 3 for 1004, but it is not the case. So we'll have to populate it in all the other records as well. So we are not keeping the base variable here when we are trying to populate ABLFL. So we are merging this at subject, param cd, ADT, visit num, and VSSeek level, and then keeping all the records which are coming from our base dataset. So even if we ignore this if a, so it should not make any difference. and the end result will be the same, because this base 02 is actually a subset dataset from ADVS 01 itself. So we cannot have any record in base 02 which is exclusively not present in ADVS 01. So in the next step, so now we have ADVS 02. So let's take a quick look at ADVS 02 along with the existing variables in ADVS 01. The one new variable that we are adding here is ABLFL. So all the other variables are actually key variables that are used to identify the baseline record. So if we go now to this dataset ADVS 02, apart from the previously seen variable still eval, so we now added ABLFL. So it is populated as Y on some of the records, which is our baseline records. So now we will move on to the next section. So wherein we will have to populate our base variable. But before that, I think I have handled the derivation completion for AVisiton here. So as per the specification for AVisiton and AVisit, we were asked to populate AVisiton as 0 when ABLFL is equal to Y. So in ADVS 02, now that we have ABLFL is equal to Y pulled into the vital signs dataset, so we can complete the derivation for AVisiton and AVisit. So if ABLFL is equal to Y, so we are assigning a value of 0 to AVisiton and the text of baseline to AVisit variable. So now the AVisiton and AVisit derivation is also complete along with ABLFL along with ABLFL variable. And then after that, we are creating our base, change, and percentage change. The base variable we have created and we have kept it in this temporary dataset called base 02. Now, what we need to do is we need to populate it across all records of that subject and parameter. So we need to keep only use subj ID, param CD, and the base variable and merge this dataset back to our ADVS 03. So we are doing that here in this step. So sort ADVS 03 based on subject ID and param CD, and then the same thing for base 02, and then merging base 02 to ADVS 03 dataset. So and in this step we are keeping only u sub jd is equal to u sub jd and param cd and the base variable. So we will now have our base variable populated on all rows of that subject and param cd. So if we go to ADVS 04, now we will have our base variable populated. So base is populated. So we can quickly examine for one subject and test CD on how base is getting populated. Let's filter for subject 1004 and then filter for dia-BP. So we have two records. So let's see which record is becoming baseline. So the baseline record has a value of 72. So as per the definition, we had to use the value from the record where ABLFL is equal to Y, which is 72, and populate it across all rows of that subject and parameter. So the filtered are the records for subject 1004 for dia-BP. So we had two records. On all the records we were expected to have the baseline value of 72, so which is coming as expected. So if we take a look at ABLFLY as well, so this subject had only two records for dia-BP. So and if we see the TRT, SDT and ADT on the record with ABLFL is equal to Y, so it says where is the ADT? Let's first see the TRT, SDT. So ADT is 2nd Jan and then TRT SDT is 5th Jan. So this record is prior to the treatment start date, and this is the latest record on or prior to the treatment start date. So this record should have become our baseline. So this is becoming baseline record as expected. So and the second record is present on 12th Jan, which is after treatment start date. So which is our post baseline record. And then now we will move on to the further derivation of change and percentage change. So here in this step, we are creating an additional variable called ANL02FL change and percentage change. Let's quickly go through the code and then see what is being done here. If ADT is greater than treatment start date greater than missing, then do ANL02FL is equal to Y. So as per the specification, we were asked to create ANL02FL or populate it as Y on the records on post baseline records, so which could be identified using ADT greater than TRT SDT. So ANL02FL was mentioned here again in this change variable derivation and post baseline percentage change variable. So it is not explicitly mentioned, but change is being calculated only on the records where ANL02FL, so which indirectly implies that percentage change also has to be calculated only on post baseline records. So if we now come back, so instead of creating ANL02FL first and then using it in subsequent step, so we are directly checking for this condition, creating our ANL02FL, and then sorry, so we are creating ANL02FL, and then we are populating our change and post baseline only on the post baseline record, which are ADT greater than TRT SDT. So ANL02FL is created, and then in order for change to be calculated, both eval and base has to be not missing. So we are creating change here as difference between eval and base. And then for percentage change, we are checking if base not is equal to 0, and then calculating percentage changes, change divided by baseline value multiplied by 100. So we have completed the derivation of base, change, percentage change, and ANL02FL. Now we are left with ANL01FL. So let's see how this is being done. So ANL01FL is being we were asked to populate ANL01FL on the record and the latest record within each visit per subject and parameter. So I am sorting the records based on the values present in U sub CD, param CD, a visit, and descending ADT. So when I sort it this way, when there exist multiple records within an analysis visit for a parameter of a subject, the record with the highest date value will be on top. So here, if I am checking if that is the first record within the analysis visit, and if a visit and not is equal to missing, then I am populating it with Y. Let's take the case of like two records with the value of 10th Jan and 11th Jan within the same analysis visit. So as I have sorted the records with descending ADT, the record with 11th Jan would come on top within that visit, and then followed by the record with 10th Jan. So first dot a visit n will become true on the record which has the date of 11th Jan. So we will be populating ANL01FL is equal to Y on that record, because as per the requirement, it was supposed to be on the latest record within that visit. So this is how we can complete the derivation for ANL01FL. So if we now move to the data sets, so I can just quickly see how ANL01FL is created. So we have ANL01FL completed as well. And then finally we are merging with ADSL to fetch other subject level variables by a simple merge. So in the initial step, so I have restricted the merge only to pull the treatment start date, because if I had fetched all the ADSL variables, so in the intermediate data sets, the number of variables will be more, and it becomes a little tough to see the newly created variables. And so for that same purpose, so I'm just keeping only the required variables in this initial merge and fetching all the other variables towards the end in a second merge after having all the variables derived. And in the next step, what we have done here is kept all the variables which are uh, to be which are present in the specification and assigned it to a macro variable named var list, and I'm using this macro variable in two steps. One is on two statements, one here on the retain statement, on the second here on the keep statement. So when I specify the list of variables here, so the variables would appear in the same order as per the specification, and then we are keeping only the variables which are listed here. Any other intermediate variables which might have been created as per the process flow would be dropped, and as they are not required as per the specification. So and we have our final ADVS dataset ready. So if we open ADVS, so we will have all the variables required, derived and available for us to use in subsequent TFL programming. So this is how we can create a simple ADVS dataset for a parallel arm study. Hope this is helpful. Thank you for watching and keep learning.